Welcome to the last video of section 3, adding a search engine with Solr and Haystack. In the previous video we've learned to create feeds for your blog posts. In this video we'll learn how to add a search engine with Solr and Haystack. Now we're going to add search capabilities to our blog. The Django ORM allows you to perform case-insensitive lookups using the IContains filter. For example, you can use this query to find posts that contain the word framework in their body. However, if you need more powerful search functionalities, you have to use a proper search engine. We're going to use Solr in conjunction with Django to build a search engine for our blog. Solr is a popular open source platform that offers full text search, term boosting, hit highlighting, faceted search, and dynamic clustering, among other advanced search features. In order to integrate Solr into our project, we're going to use Haystack. Haystack is a Django application that works as an abstraction layer for multiple search engines. It offers simple search API very similar to Django query sets. Let's start by installing and configuring Solr and Haystack. Installing Solr. You'll need the Java Runtime Environment version 1.7 or higher to install Solr. You can check your Java version using the command Java version in the shell prompt. This output might vary, but you need to make sure the installed version is at least version 1.7. If you don't have Java installed or your version is lower than the required one, you can download Java from this site. After checking your Java version, download Solr version 4.10.4 from this site. Unzip the downloaded file and go to the example directory within the Solr installation directory. This directory contains a ready-to-use Solr configuration. From this directory, run Solr with the built-in Jetty web server using this command. Open your browser and enter the URL in your browser and you'll see the Solr page in your screen. This is the Solr Administration Console. This console shows you usage statistics and allows you to manage your search backend, check the index data, and perform queries. Creating a Solr core. Solr allows you to isolate instances in cores. Each Solr core is a Lucene instance along with a Solr configuration, a data schema, and other required configuration to use it. Solr allows you to create and manage cores on the fly. The example configuration includes a core called Collection 1. You can see the information of this core if you click on the Core Admin menu tab. We're going to create a core for our blog application. First, we need to create the file structure for our core. Inside the Solr directory, create a new directory and name it blog. Then create these empty files and directories inside it. Add this XML code to the solrconfig.xml file. You can also copy this file from the code that comes along with this section. This is a minimal Solr configuration. Edit the schema.xml file and add this XML code. This is an empty schema. The schema defines the fields and their types for the data that will be indexed in the search engine. We're going to use a custom schema later. Now click on the Core Admin menu tab and then click on the Add Core button. You'll see a form like in the screen that allows you to specify the information for your core. Fill the form with the data as the same on the screen. Name, blog. The name field is the name you want to give to this core. Instance directory, blog. The instance directory field is the directory of your core. Data directory, data. The data directory is the directory where indexed data will reside. It's located inside the instance directory. Config, solrconfig.xml. The config field is the name of your Solr XML configuration file, schema.xml, and the schema field is the name of your Solr XML data schema file. Now click the Add Core button. You'll see that your new core has been successfully added to Solr. Installing Haystack. To use Solr with Django, we need Haystack. Install Haystack via pip using this command. Haystack can interact with several search engine backends. To use the Solr backend, you also need to install the pysolr module. Run this command to install it. After installing Django Haystack and pysolr, you need to activate Haystack in your project. Open the settings.py file and add haystack to the installed_apps setting like this. You need to define the search engine backends for haystack. You can do this by adding a haystack_connections setting. Add this into your settings.py file. Notice that the URL points to our blog core. Haystack is now installed and ready to be used with Solr. Building indexes. Now we have to register the models we want to store in the search engine. The convention for Haystack is to create a search_indexes.py file into your application and register your models there. Now, create a new file into your blog application directory and name it search_indexes.py. Add this code to it. This is a custom search index for the post model. With this index, we tell Haystack which data from this model has to be indexed in the search engine. The index is built by subclassing indexes.searchIndex and indexes.indexable. Every search index requires one of its fields has document equals true. The convention is to name this field text. This field is a primary search field. With use template equals true, we're telling Haystack that this field will be rendered to a data template to build the document the search engine will index. The publish field is a date time field that will also be indexed. We indicate that this field corresponds to the publish field of the post model by using the model_attr parameter. Field will be indexed with the content of the publish field of the index post object. Additional fields like this one are useful to provide additional filters to searches. The getModel method has to return the model for the documents that will be stored in this index. The index_querySet method returns the query set for the objects that will be indexed. Notice that we're only including published posts. Now create the path and file search/indexes/blog/post_text.txt in the templates directory of the blog application. And add this code to it. This is the default path for the document template for the text field of our index. Haystack uses the application name and model name to build the path dynamically. Every time we're going to index an object, Haystack will build a document based on this template and then index the document in the Solr search engine. Now that we have a custom search index, we have to create the appropriate Solr schema. Solr's configuration is XML based, so we have to generate an XML schema for the data we're going to index. Fortunately, Haystack offers a way to generate the schema dynamically based on our search indexes. Open the terminal and run this command. You should see an XML output. If you take a look at the bottom of the generated XML code, you'll see that Haystack generated fields for your post index automatically. Copy the whole XML output from the initial tag to the last tag, including both tags. The XML is the schema to index data into Solr. Paste the new schema into the blog/conf/schema.xml file inside the example directory of your Solr installation. The schema.xml file is included in the code that comes along with this section, so you can also copy it directly from this file. Open this link in your browser and click on Core Admin Menu tab. Then click on the Blog Core, and then click on the Reload button. We reload the core so that it takes into account the schema.xml changes. When the core finishes reloading, the new schema is ready to index new data. Indexing data. Let's index the posts of our blog into Solr. Open the terminal and execute this command. You should see the warning message like this. Enter Y for yes. Haystack will clear the search index and insert all published blog posts. You should see an output like this. Open the blog in your browser. Under Statistics, you should be able to see the number of indexed documents as follows. Now, open this link in your browser. This is a query interface provided by Solr. Click the Execute Query button. The default query requests all documents indexed in your core. You'll see a JSON output with the results of the query. The outputted documents look like this. This is the data stored for each post in the search index. The text field contains the title, tags separated by commas, and the body of the post, as this field is built with the template we defined before. You've used Python manage.py rebuild_index to remove everything in the index and to index the documents again. To update your index without removing all objects, you can use Python manage.py update_index. You can set up a cron job for this in order to keep your Solr index updated. Creating a search view. Now we're going to create a custom view to allow our users to search posts. First, we need a search form. Edit the forms.py file of your blog application and add this form. We'll use the query field to let the users introduce search terms. Edit the views.py file of your blog application and add this code to it. In this view, first we instantiate the search form that we created before. We're going to submit the form using the get method so that the resulting URL includes the query parameter. To see if the form has been submitted, we look for the query parameter in the request.get dictionary. When the form is submitted, we instantiate it with the submitted get data and we check that the given data is valid. If the form is valid, we use search query set to perform a search for index post objects whose main content contains the given query. The load all method loads all related post objects from a database at once. With this method, we populate the search results with the database objects to avoid per object access to a database when iterating over results to access object data. Finally, we store the total number of results in a total results variable and pass the local variables as context to render a template. The search view is ready. We need to create a template to display the form and the results when the user performs a search. Create a new file inside the templates/blog/post directory. Name it search.html and add this code to it. As in the search view, we distinguish if the form has been submitted based on the presence of the query parameter. Before the post is submitted, we display the form and a submit button. After the post is submitted, we display the current query performed, the total number of results, and the list of results. Each result is a document returned by Solr and encapsulated by Haystack. We need to use result.object to access the actual post object related to this result. Finally, edit the urls.py file of your blog application and add this URL pattern. Start the development server by typing the command python manage.py run server as shown on screen. Now, open the blog in your browser. You should see a search form like this. Now enter a query and click the search button. You'll see the results of the search query like this. Now you have a powerful search engine built into your project, but starting from here there are plenty of other things you can do with Solr and Haystack. Haystack includes search views, forms and advanced functionalities for search engines. Good job! We've successfully added a search engine with Solr and Haystack. This video concludes the third section of this course. In this section you learned how to create custom Django template tags and filters to provide templates with custom functionality. You also created a sitemap for search engines to crawl your site, and an RSS feed for your users to subscribe to. You also built a search engine for your blog by integrating Solr with Haystack into your project.
This brings us to the end of our course. I hope you're now confident to build a blog application and modify it to suit your needs. I had a lot of fun on this journey. I hope you did too.